Okay, this is Chapter 1, Section 1, so 1.1, Example 1. Anthony worked all summer to save $1,950 for spending money during the school year. He plans to withdraw the same amount from his savings account at the end of each week. Anthony can create an arithmetic sequence that shows the balance of his savings account at the beginning of each week of the school year. Okay, so this would be week 1, this would be week 2, this would be week 3. How much money will be in Anthony's savings account at the beginning of the 4th week of the school year? How much money will be in Anthony's savings account at the beginning of the 5th week of the school year? Okay? Before continuing, I would pause the recording and read this again at least once to let it sink in. Alright. So first thing we want to look at is, what's the difference between all these? What are we doing to go from one to the next? Well, to get from the first to the second, we are subtracting 65. Okay, that's a good observation. Let's look between the two and see if it's the same. And we will find, yes, it's the same. So since we are subtracting, adding or subtracting, this is an arithmetic sequence. An arithmetic sequence, not geometric. So here we go. Bum, 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 bum. If I want item number 4, I simply take the one before it, and we're going to apply our pattern. Subtract 65. So 820 minus 65 is 1755. That's how much money he'd have at week 4. For week 5, same idea. So for a sub 5, we simply take the one before it, a sub 4, and again we subtract 65. So 1755 minus 65, stick in your calculator, you get 1690. That's how much he has at week 5. Now, I know this one doesn't tell you to do it, but let's create a rule. A rule is simply just another way of saying equation, but let's create a rule for this. The rule, remember, for arithmetic, you just look on the page to the left and look at it, is a sub n equals a sub n minus 1, so that basically means whichever one I want, I take the one before it, and in this instance, we are subtracting 65. So this is the rule. This is the equation that will take me from one step to the next. Alright? Let's keep on going. Alright, at this point, I want you to, this is you try it number 1. I want you to try it. Alright, give it a shot. See what you can do with it. And then come back, pause the recording, come back and do it. Alright? So hopefully you've tried it now. But for this one, it says Rachel helps the student council create a paper chain that contains students' written pledges not to bully or tolerate bullying. Okay? When Rachel begins stapling, there are 54 inches of paper chain. She measures after adding each link and records the data. What is the common difference in this situation, and how long will the paper chain be after Rachel has added a total of 6 links to it? What is the common difference, and how long will the paper chain be after Rachel has added a total of 6 links to it? Okay, so here we go. With the first link, we have 58.5. Okay, so to get to the second one, to get up to 63, we're adding what? 4.5? 4.5? I don't care if you use decimals. 63 minus 48.5 is 4. No, it's not 4.5. 69, 59, 60, 61, 62. Yeah, 4.5. All right. To get from 63 to 67 is, again, we are adding 4.5. 63, 64, 65, 66, 67, plus 5, 67.5. All right. So we'll notice, if you wanted to write your rule, whatever a sub n, if whichever one I want, I take the one before it, And in this case, we're adding 4.5. So let's see here. Just follow the pattern. For number 6, add 4.5. So that's 68 plus 4 is 72. Not for number 6, I'm sorry. For number 4. For number 5, take the one before it and add 4.5. So 72 plus 4.5 is 76.5. All right. For number 6, take the one before it and add 4.5. So that would be plus 4.5. That's 7, 8, 9, 10, 11. That would be 81. Okay. After adding 6 links, her chain would be 81 inches long. And Mr. Hunter needs to learn how to spell inches. Let's try this again. Wow, what did I just do? Just give up. INCHES. No, never give up. That's how you fail math, is by giving up. All right? All right. Good.